Survey of Calculus, Chapter 2, Section 7, an economics application, elasticity of demand. First of all, what is elasticity of demand? Well, when retailers and manufacturers set prices, they often need to know how a small change in price will affect the demand for the product, because generally speaking, you can get to a point where the higher the price is, the less demand there is for that, and then that's going to affect your profit. If a small increase produces no change in demand, then it makes sense to increase the price by that amount. However, if a small increase in price is going to create a drop in the demand, it's probably not a good idea to do that, and they need to have a way of figuring out is this going to cause a drop in the demand or not. So to measure the sensitivity of demand to a small percent increase in price, economists calculate what's called the elasticity of demand. Here's the formula for it. E is the symbol for elasticity, and X stands for the price. So it's negative, and then you have a fraction, X, the price, times d prime of X, the derivative of demand at the price X, over d of X, the demand function with X put in, with the price put in for X. So there's our formula. This is on your formula sheet, so you don't need to memorize it, but you do need to know how to use it. So let's try an example. Click's Video has found that demand for rentals of its DVDs is given by Q of X, Q equals D of X, which is 120 minus 20X. Again, remember X is the price. Q is the number of DVDs rented per day, that's your demand, X dollars per rental. Find each of the following. So we're going to find the quantity demanded when the price is $2. We're going to find the elasticity function. We're going to find the elasticity at X equals 2 and X equals 4, and we're going to tell what it means. And we're going to find the value of X, which gives us an elasticity of 1, and interpret that. And then we're going to find the total revenue function, which total revenue is the price times the demand. It's how much you're charging times how much you're going to rent, in this case, or sell. And we're going to find the price at which total revenue is maximum. So we got a lot to do here. If you want to give some of these a try yourself, pause the recording and give them a try. And if not, if you'd rather kind of follow through with this one, then just keep going and we will go through each part. Okay, so for part A, the demand equation is 120 minus 20X. So substituting in 2 for X, we get 80. So 80 DVDs per day will be rented at a price of $2 per rental. Now we need to find, for part B, the derivative demand. The derivative of 120 minus 20X is negative 20. We'll put this and the demand equation into our elasticity formula. So negative X times d prime of X over d of X equals X times negative 20 over 120 minus 20X. So we get the two negatives cancel, so we have 20X over 120 minus 20X, and then we can cancel a 20 out of everything and get X over 6 minus X. So that is the elasticity formula for this particular situation. Elasticity when the price is 2 and when the price is 4. So we found our formula for elasticity. We just need to put in 2, and we get 1/2. The elasticity is 1/2, which is less than 1. So the ratio of the percent change in quantity to the percent change in price is less than 1. When the elasticity is less than 1, a small percentage increase in price will cause an even smaller percentage of decrease in the quantity. So you're not going to lose very many people if you increase it by a small percent. And then find E of 4. If you're charging $4 and you go up, you get an elasticity of 2. 2 is greater than 1. So the ratio of the percent change in quantity to the percent change in price is greater than 1, which means if you're already charging $4 and you go up a little bit, you're actually going to lose more customers, and it's going to not make it worth increasing that price. For part D, we're going to take our elasticity formula, X over 6 minus X, and set it equal to 1, and solve for X. And we get 3. What this is saying is that when the price is $3, the ratio of the percent change in the quantity to the percent change in price is 1. And then finally, we're supposed to, last two here, we're supposed to find the total revenue, which is x times d of x. So x times 120 minus 20x, and we get 120x minus 20x squared, so we just distribute it. And then we're supposed to find the price that maximizes our revenue. So we take the derivative, and that gives us 120 minus 40, and we get 3. So we can use the second derivative test to prove that this is a maximum. When you put 3 into, well, when you take the second derivative, you get negative 40, which means the entire graph is concave down. So 3 must be a maximum. So the total revenue is a maximum at $3 per rental. So we're going to make the most money when we're charging $3 per rental. Okay, so we have this theorem that says total revenue is increasing, going up, at x values that give you an elasticity of less than 1. So if your elasticity is less than 1, if it's a fraction between 0 and 1, then the total revenue is increasing. If it's decreasing, if you do the elasticity for that price and you get a number greater than 1, then your revenue is actually going to start going down in how much you're making. And then total revenue is maximized when your elasticity is exactly 1. So really, that's kind of your ideal situation. You want the elasticity to equal 1. Elasticity in revenue for a particular price, the demand is inelastic if your elasticity is less than 1. What that means is that an increase in price will bring an increase in revenue. If the demand is inelastic, the revenue is increasing. The demand has unit elasticity if E of x equals 1. And that's when your revenue is at a maximum. So when E of x equals 1, revenue is at a maximum, and it's called unit elasticity. The demand is elastic if your elasticity is greater than 1. An increase in price will bring a decrease in revenue. If demand is elastic, revenue is decreasing. Okay, so we need to keep those straight. When revenue is increasing, it's inelastic. When it's decreasing, it's elastic. And when it is maxed, the elasticity equals 1. It has unit elasticity. Okay, here's kind of a little graph of that. Here's your demand function where it's inelastic. My elasticity is less than 1. It's elastic when it equals 1, and then when it's greater than 1, it's elastic. It's unit elasticity when it equals 1. Okay, this is looking at the total revenue and price. The previous graph was demand. This is revenue. Okay, when your revenue is increasing, you have an inelastic demand. When it's decreasing, you have an elastic demand, and then the price, right at the top there is where you are maxing out your revenue. Your elasticity is 1. Okay, so let's try another one. This is Click's videos again, and internet rentals are affecting them, so that the demand of rentals has changed to 30 minus 5x. So try these on your own. Go through and find the demand when price is 2, 3, and 5. Find the elasticity function. Find the elasticity at 2, 3, and 5 and interpret them. Find the value for x that gives you an elasticity of 1. Find the total revenue and the price when revenue is a maximum. Pause the recording, give these a try, and resume to check your answer. All we had to do was put in 2, 3, and 5 to the demand function. And we'll notice at $2, the demand is 20. At 3, it's 15. And at 5, it's 5. When we do our elasticity, the derivative of 20 minus 5x is negative 5. Our elasticity function is x times negative 5 over 30 minus 5x. And then what we're going to do is divide everything by 5. And we get x over 6 minus x. Then we do e of 2. Well, when we put in 2, we get 1/2. We'll interpret this in a minute. E of 3 is 1, and E of 5 is 5. So when x is 2, the elasticity is 1/2, which is less than 1. So the ratio of the percent change in quantity to percent change in price is less than 1. A small increase in price will cause an even smaller percentage decrease in the quantity. So here this would be inelastic. At x equals 3, the elasticity is 1, so it has unit elasticity. The ratio of percent change in quantity to price is 1. A small percent increase in price will cause an equal percent decrease in quantity. And then at 5, the elasticity is 5, which is greater than 5, or greater than 1, which means that it is elastic. The ratio of the percent change in quantity, percent change in price is greater than 1. A small price increase will cause a larger percentage decrease in the quantity. And then we're going to find the value when e of x equals 1. And we actually should know this already. We found that it's 3. And so at $3 per rental, then we get a percent change in price of $1. Find the total revenue function, and we get 30x minus 5x squared. And we get 30 minus 10x. And that equals 0 when x is 3, which should not surprise us because we already said when x is 3, it has an elasticity of 1, and that's when your revenue is at a maximum. So you're making maximum revenue at $3 per rental. Here's our summary. You might want to pause and look over this and then resume to do some practice. Okay, the rest of these are practice problems. Pause the recording as you go through and resume to check your answer.